In today's video, we're going to be talking about simplifying radicals. So our goal is to take something that looks like this, square root of 50, and simplify it to make it look like this. Okay? Last year, you were told to estimate. This year, we're going to be simplifying. So our goal is to take an irrational number and simplify it. Let's look at the next slide. Okay, so our title is Simplifying Radicals. A radical expression is an expression that contains a radical symbol, such as a square root. Square roots are when you take the square root of a number, you're asking yourself what number times itself gives me the number under the radical. When we have perfect squares under the radical, we get integers. So perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So a number times itself, that result is a perfect square. Okay? You will remember from last year that if I asked you, what is the square root of 16? You ask yourself, hey, what number times itself gives us 16? And that answer would be 4, because 4 times 4 gives us 16. What if I ask the square root of 144? Our answer would be 12. 12 times 12 gives us 144. But what if it's not a perfect square? Okay? If it's not a perfect square, we're not getting pretty numbers. We're going to end up with something like this again. Still having a square root. Not going to be a pretty number. So our goal today is to simplify it, not get an exact number. There are two methods we can use. The first method, we're going to call it the jailbreak method. First step you're going to do is to create a factor tree. Okay? To create factor trees, you need to find all of the prime numbers that are inside that original number. A prime number is a whole number greater than 1 whose only factors are 1 in itself. I have listed the different examples of prime numbers. Okay, these will be very helpful when you're breaking it down into your factor tree. After we're completely factored, only pairs of like numbers get to escape the radical. Okay? After they escape, we're going to multiply the numbers that have escaped together and multiply the numbers still trapped back together. So that's going to make more sense when we go over it. So let's talk about an example. Okay, so we're going to simplify. First one, we're going to do a nice little easy one, square root of 8. We're going to create that factor tree right there. So what numbers or what multiplies to give me 8? I can have 2 times 4. 2 is a prime factor, so I'm done on this side. But 4 is not a prime factor. I have to break it up. What multiplies to give me 4? 2 times 2. Okay. We have completely factored. So now we're just looking at, I have 2 times 2 times 2. Our directions say after we completely factor, we look for pairs. Okay, we're looking for pairs only. So I have a 2 right here, and I have a 2 right here. I have a third one, but it doesn't have a pair. It does not have a buddy, so we cannot include it. It's only included if it has a buddy. Right? So these two get to escape, but when they get to escape, we pull out only one of them. So to get out, you need a pair. Once we pull it out, there's only one that's left on the outside. Okay? This is thinking of like, hey, square root of 4. 2 times 2, only one of them got out of that square root. But then I still have this 2. He's trapped. He's stuck underneath that radical. He's trapped and stuck underneath that radical. So our final, the only thing we can do is simplify it to look like this. 2, the square root of 2. to the square root of 2. Let's look at another example. I have the square root of 360. Okay, this is a larger number. I know it's even, so I could divide it by 2 if I wanted to. Okay, so I could do 2 times 180. But 180 could be broken up again. Since it's even again, I could still break it up into 2. So 2 times 90. 2 is a prime factor, but 90 still not. So we'll break 90 up, which will give me 2 times 45. Okay, 2 is a prime factor. 45 is not, so we got to keep on going. Okay, 45 would be 5 times 9. 5 times 9. 5 is a prime number, but 9 is not. 3 times 3 will give us 9. Okay, and 3s are prime numbers. So we have our complete tree here. Now we got to look for partners in crime. Okay, I have a set of 2s. This 2 cannot be included. It needs its own friend. There's not another 5, but I have 2 3s here. I have 2 3s, so they get to escape too. So when I find my pairs, I pull them out. So I'll have 2 times. I could pull out a 3. So 3 goes out here. Write our radical. And then who didn't get to escape? I have a 2 that didn't get to escape and a 5 that didn't get to escape. A 2 and a 5. Now we move on to step 3. Step 3 says multiply whatever you pulled out. Okay, so 2 times 3 gives us a 6. And then multiply what's still trapped. Okay, put our square root, it's trapped. 2 times 5 gives us 10. So our simplified version of the square root of 360 is 6 square root of 10. One more. What if I had -5 already pulled out of here, and then 132? And I'm asking you to simplify. Okay, I see that this one is still even, so I definitely can multiply by 2 to get something. Okay, 2 times 66 gives us 132, but 66 is not done yet. So I have 3 times 2. Ooh, not times 2, times 33. Times 22. Ooh, times 22. But 22 is not simplified yet. We could still break that up. We can break that up into 2 times 11. 2 times 11. 11 is prime, 2 is prime, 3 is prime, and 2 is prime. Now we gotta find pairs. Do we have buddies? Okay, I have 2 2s, so they could escape. But I only have 1 3, so he can't escape. I only have 1 11, so that one can't escape. So only the 2s get to escape this one. We're going to put equals. Since this -5 is already here, we're going to rewrite it and we're going to multiply it by whatever we pull out. Okay? So the 2s get to escape. So we're going to do -5 times 2. We put our square root. And then what's still left over? Okay, 3 didn't get to escape, and 11 didn't get to escape. So 3 times 11. Now we do our multiplication. -5 times 2 gives us -10. And then 3 times 11 gives us 33. And that's all we could do to simplify.